Welcome back to the Neural Intel Pod. We're diving deep into a paper today that's all about making AI smarter, especially when it comes to reasoning. We all want AI that can really solve problems, not just like repeat information.
Yeah, definitely. It's about going beyond just processing information. We're talking about AI that can understand and reason. It's a fascinating challenge.
Exactly. And the paper we're looking at is titled Vision-R1, Incentivizing Reasoning Capability in Multimodal Large Language Models. A bit of a mouthful, but it highlights those two key ingredients,
Yeah.
multimodal and reasoning. Multimodal meaning the AI can handle both text and images.
Think of it like solving a geometry problem. You've got the diagram and you've got the word problem. You need both to fully get it, right? Multimodal AI tries to do the same process both to really understand what's going on.
So like giving AI the ability to see and read. But the really tricky part is the reasoning part. Can we actually teach AI to think logically? Like figuring out a multi-step math problem or understanding a complex scene?
Right, and that's where chain of thought, or kati, comes in. It's basically like giving the AI a notepad to jot down its thought process as it goes.
How interesting. So by making those thinking steps explicit, we can like peek into the AI's brain and see how it's approaching the problem.
You could say that it's a way to make the AI's reasoning more transparent and hopefully more like how we humans think.
Now, one way we teach AI is through reinforcement learning, or RL. It's kind of like giving a dog a treat for doing a trick. You reward the AI for getting closer to the right answer. And RL has been amazing for AI, especially in like game playing.
Oh, for sure, it has. But there's a bit of a catch when it comes to this whole multimodal reasoning thing. Researchers tried directly applying RL to these multimodal large language models, or MLLMs, and it just wasn't really working.
So the AI wasn't getting the treats, or in this case, the rewards. What was the problem?
Well, there were actually a couple of issues. Firstly, there just wasn't enough high-quality data out there to train the AI on reasoning across both text and images. Imagine trying to teach someone, I don't know, advanced calculus before they even know basic arithmetic. It's just not going to work very well.
So you're saying we need to give the AI a solid foundation in those basic reasoning skills before throwing it into the deep end of complex problem solving.
Exactly. And that leads to the second issue. Even if we did have enough data, directly applying RL can take a long time to train, like really long time. It's just not that efficient.
Gotcha. So they needed a smarter approach, something faster and more targeted. That's where Vision R1 comes in, right?
Yes. Vision-R1 uses a two-step approach. It combines cold start initialization with RL training. It's like giving the AI a head start in the reasoning game.
Okay. I like where this is going. Tell me more about this cold start.
So instead of starting from scratch with the RL, the researchers created a special data set of what we call multimodal Fokker and key examples. These examples are specifically designed to, showcase basic reasoning skills. It's almost like a primer for the AI.
Ah, okay. So they're basically providing the AI with some initial building blocks for reasoning.
Exactly. And to create these examples, they use this cool technique called modality bridging. It's essentially like translating images into a language that the AI can understand. Almost like giving it subtitles for a movie, but for pictures instead.
Interesting. So they're creating this special dictionary where pictures have their own AI-readable definitions.
You could think of it that way. And what's really neat is that they actually used an AI they had previously developed called DeepSeek-R1 to help create these examples. DeepSeek-R1 is a text-only reasoning AI, and they used it to help build this multimodal reasoning foundation. Then they bring in the RL training to really refine those reasoning skills and take it to the next level.
Okay, so cold start sets the stage, then RL comes in to fine-tune everything. Sounds pretty clever.
It is. But of course, nothing is ever that straightforward. Even with the cold start, they ran into another problem. The AI would sometimes get stuck in these super long, overly complex reasoning chains, which often led to, well, the wrong answers. They call this the overthinking optimization problem.
Haha. Even AI can overthink things. I think we've all been there.
Oh, absolutely. And just like we need strategies to avoid overthinking, the researchers needed a solution for the AI. That's where something called progressive thinking suppression training, or PTST, comes in.
Okay, PTST, another acronym to add to our list. So what does this one do?
Imagine you're learning to ride a bike. You wouldn't start on a mountain trail, right? You need those training wheels first. Then you slowly increase the difficulty. PTSD works kind of like that. It starts by limiting the number of thinking steps the AI is allowed to take. This prevents it from going down those rabbit holes of incorrect reasoning too early on.
So it's like putting training wheels on the AI's thought process. You're guiding it towards more complex reasoning without letting it get overwhelmed.
Exactly. As the training goes on, they gradually loosen those restrictions, allowing the AI to tackle more and more complex problems.
So we've got our foundation with cold start, our training wheels with PTSD, and RL as our coach. Now the big question, did this whole elaborate training scheme actually work? Did Vision-R1 live up to the hype?
Well, that's where things get really interesting. Let's dive into Vision R1's performance. Vision R1's performance was really something, especially considering its size.
Hold on, size matters in AI. Is it like, bigger brains are better?
Well, not exactly brain size, but it's kind of similar. Larger AI models, ones with more parameters, tend to be better at learning and solving those really tough tasks. It's like having a bigger toolbox with more specialized tools. But what's really cool about Vision R1 is that even with a relatively small number of parameters, like 7 billion, it went toe-to-toe with much larger models on all these different math reasoning tests.
Okay, so it's like this little engine that could, so how well did it actually do?
Well, for instance, on Math Vista, which is like a gold standard benchmark for mathematical reasoning in AI, Vision R1 scored a pretty impressive 73.5%. And to give you an idea, that's only slightly behind OpenAI's O1 model, which is a much larger model and, considered a front runner in this whole domain.
73.5%. That's not bad at all. So even though it's smaller, Vision R1 is proving it can hold its own. What about those other benchmarks you mentioned? Did it do well there too?
Oh, absolutely. On MathVerse, another benchmark that focuses on this kind of multimodal mathematical reasoning, Vision R1 actually came out on top, performing better than all the other models they tested. And on MMath, it secured a very close second place, only surpassed by a model that's like many times its size, the Qwen 2.5 VL72B, which has a whopping 72 billion
Wow,
parameters.
it's a huge difference. So it seems like it's consistently ranking near the top,
Yeah.
even when compared to these much larger models. It really makes you wonder, though, about that gold star data set. How can we be sure it's actually helping the AI reason better? Could they have just used RL training on a different data set and gotten similar results?
That's a great question. And to test that, the researchers actually did a cool experiment. They took another large language model called Llama 3.2 11B Instruct, and they trained it using two different methods. The first was just direct RL training, and the second involved using their cold start initialization and then doing the RL training.
So it's like a head-to-head comparison, seeing which approach works better.
Exactly. And the results were pretty telling. The model that got that cold start initialization, which they called Vision R1 Llama VCI 11B, consistently did better than the model that only had the RL training, and that was across all the benchmarks they used.
Okay, so it seems like that cold start method is really giving the AI a leg up in learning those reasoning skills. But remember we talked about that overthinking problem where the AI could get caught in these really complex reasoning chains. Did that PTSD method actually fix that issue?
To really see how PTSD was affecting things, they tested several different versions of the model. One, which they called Vision R10, used just RL training without any of the cold start stuff. And as you might expect, this one had trouble coming up with those complex reasoning chains and didn't really do well on the harder problems. It's like trying to run a marathon with zero training.
Yeah, makes sense. So what about the other versions?
Well, there was one called Vision R1CI, which had the cold start initialization but didn't use PTSD. And this one tended to, well, overthink things. It came up with those super long, complicated reasoning chains that often led to wrong answers. Then they had Vision R1 Long, which used RL but with a fixed maximum length for those reasoning chains. It's kind of like putting a word limit on the AI's thinking.
Interesting. So instead of slowly increasing the complexity, they just set a hard limit.
Yeah, but while it did a bit better than Vision R1CI, it still had some optimization struggles and didn't show much improvement.
It seems like finding that sweet spot between thinking too much and not thinking enough is key.
Exactly, and that's where Vision R1, the one with PTSD, really shines. That's the one that gradually increases how long those reasoning chains can be, like those training wheels we talked about.
Right, right. And that's the one that got those impressive results on Math Vista and the other benchmarks.
Yep. The results clearly show that PTSD really helps guide the model towards more complex reasoning, but without letting it fall into that trap of overthinking. It's all about balance.
So they've shown that this combination of cold start initialization and this progressive training can lead to really impressive results.
Hmm.
It seems like we're actually making progress towards AI that can reason more like us. But before we get carried away, what are some of the limitations of Vision-R1? What are the next steps in this research?
Well, that's a great question. While Vision-R1 is definitely a step in the right direction, there's still a lot of work to be done. Vision-R1 is definitely exciting stuff. But it's important to remember that this is still pretty early stage research. There are definitely some limitations and lots of room for improvement.
So where do we go from here? What are some of the next big steps on this road to truly reasoning AI?
Well, one thing that researchers are really interested in is expanding the types of reasoning tasks that AI can handle. Right now, Vision-R1 is amazing at math, but the world is full of other kinds of logic.
Yeah, I see what you mean. It's like we've taught it to solve equations, but what about understanding like cause and effect
Yeah.
or making decisions in those messy real-world situations?
Exactly. We need AI that can reason about all the complexities of the world, not just solve equations on a piece of paper.
So things like causal reasoning, understanding why things happen, or spatial reasoning, being able to navigate through a complicated environment.
Exactly. Those are all crucial for AI to truly understand the world around us, not just the world of math problems.
So it's about going beyond just number crunching and teaching AI to think more broadly, to think more like how we humans reason about everyday situations.
Right. And another challenge is, well, transparency. Even with Cody, where we can see those steps the AI is taking, it can still feel a bit like a black box. You know what I mean?
Yeah, I get it.
Yeah.
Even if the AI gets the right answer, we might not really understand how it got there. We need that transparency if we want to trust AI's reasoning, especially when it starts making decisions that affect us.
Absolutely. Trust and understanding go hand in hand. Researchers are working on ways for AI to explain its reasoning, but in a way that makes sense to us humans. Imagine being able to ask the AI, why did you choose that solution? And it gives you a clear explanation that you can actually follow.
That would be amazing. It would be like having a conversation with the AI about its thoughts, not just getting this final answer that we don't really understand.
Right. And of course, there's the question of scalability. Vision-R1 did really well with a relatively small model, but can this approach be scaled up to those much larger, more complex AI systems? That's a big question that researchers are still trying to figure out.
If we can crack that, the possibilities are pretty much endless. We could have AI helping us with everything from designing new medicines to like composing music, and we'd actually understand how it's doing it.
It's definitely a future with huge potential. Vision-R1, with those techniques like the cold start initialization and the progressive training, it really provides this great blueprint for developing even more capable reasoning AI.
Well, it's clear that this is a field that's moving really fast, and Vision-R1 is a really exciting step forward. For our listeners who want to get into the nitty-gritty details of this research, be sure to check out the link in our bio. It's a fascinating read and a great way to stay up to date on all the latest AI breakthroughs.
Yeah, and keep an eye out for what comes next. This is just the beginning of truly reasoning AI.
That wraps up our deep dive for today. Catch you next time on the Neural Intel Pod.